Hello, this is Aaron Lewis from Franklin Maths. This lesson is about the normal distribution. It's called finding mu and sigma, or finding the mean and standard deviation. This lesson is a follow-on from the previous ones, so make sure you've done those first before attempting this. So I'm going to dive in with straight away what the questions look like. As I say, normally in this part of the stats module, I've put the questions in context because the actual math isn't too bad to cope with. So here we've got a normal distribution and we're given the standard deviation. And we're also told a little bit more information, but we're not given the mean. Okay, so the first thing to do is just to sketch it. Okay, and obviously we don't know what mu is here. We have no idea, but we do know that the standard deviation is 2. So this is mu plus 2, mu plus 4, mu plus 6. Okay, now from here we must work out what this would look like on the diagram. Now it says when x is greater than 4, we get an area or a probability of 0.2. Now if you think about the way this works, if I say that is approximately 4, so when it's greater than 4, we get an area of 0.2. Okay, if you say x was less than 4 with an area of 0.2, I would have drawn it the other way. Okay, so that's quite a good little skill to do. And as I say, every normal distribution question, I tend to sketch them and write down anything I can. It makes your life a little bit easier because you can see what's going on. Now, I mentioned this in previous videos, and that's the standard normal distribution, which is something like this. Now, remember, for the standard normal distribution, this is z tilde, and so z is approximated by normal distribution. And remember with this, the mean is 0, and the standard deviation is 1. Okay, so 0, 1, 2, 3. And remember from previous videos, this tells you how many standard deviations it is away from the mean. Now, this process here of turning this into this one, it's called standardizing. Okay, it's very, very easy to do. So all I'm going to do is literally copy what I've got here, and it's all I'm doing is copying this bit. I'm not going to take the 4 because that won't make any sense, but I'm going to draw a line in approximately an area of 0.2. Now, it might not be right here. It doesn't really matter. I'm not getting overly stressed about that. So if I just draw in a line there, so the area of this one is 0.2. Well, the question is, how does that help? Well, if we pick up our calculator, we can use the inverse button and find out what number this is. Okay, so I'm just going to pull up the calculator, and there, look, my calculator has now appeared. So again, I'm going to dist, I'm going to norm, I'm going to inverse this time because we know the area, we know the probability, and we've got it is a variable. As you can see, I've already had a go at this. It's a right tail. The area is 0.2. Sigma is 1. Mu is 0. And press execute then. And that gives me this number here. Again, my picture isn't drawn fantastic here. But we know that this value here is 0.8416. We'll take it to 4SF. 8416. So to get an area of 0.2, it needs to be 0.8416 standard deviations away from the mean. Now, how does that help? Well, if you go back to the formula that we used the other day, or the previous video, so this one would have been x tilde n, and it was mu, and it's 2 squared, so it's 4. Now, the formula we got the other day in terms of converting z-scores, and the one that you guys need to know for your exam is z. So the z-score is equal to. Now remember, these two are the same, apart from the mean has been translated. So it's going to be x minus mu. So that's the translation coming in there of the distribution. And I say I haven't shown this in videos, but I think I'm going to on Desmos. But if you make the standard deviation smaller, it makes this like sort of thinner, and if you make mu larger, it does stretch it out. Okay, and we would divide that by the standard deviation like that. So that formula you need to know. Now we're going to fill in what we know. We know x. X was 4. We don't know mu. We know that the standard deviation was 2. And we know this value here was 0.8416. So the next thing I need to do is to multiply through by 2 and subtract that from 4, or rearrange the equation. It's entirely up to you, but this shouldn't be too difficult to do. And let's have a look then. So I've grab a calculator a second, and so you would get 1.68. Oops. 6832 is equal to 4 minus mu. I mean, it's up to you if you want to rearrange this, but you can add mu to both sides, subtract 1.68 from both sides. Either way, mu is going to be equal to 2.316a, and the question wanted it to 2SF, so in that case then mu is equal to 2.3, which is what we expect. We're certainly expecting mu to be less than 4. Okay, so the key with these sorts of questions is to sketch it, fill in what you know, draw the standard normal distribution, find out a z-score, and then work it through the formula. So it's quite nice to do. It's just getting the hang of how it all works and how it all fits together. You might have come across the term standardizing when they talk about standardized testing. In general, most tests when done on a large number of students tend to look like this. Okay, and here's another question. You'll notice with this one this time, we're asked to calculate the standard deviation rather than calculate the mean. Okay, so we're going to do exactly the same thing. We're going to follow exactly the same process and see what we can work out. Okay, so as I say, there's my two pictures, and I'm going to fill in what I know on this one. So this is going to be x tilde n, and so we're told it has a mean of 10, and we don't know what sigma is, but we need to write sigma squared in there. And then let's fill in what we know. So we know that this is 10. We know that 11 is here somewhere. Again, I'm not going to get overly stressed about whereabouts it is. It's just more a visual representation of what's going on. And again, because x is greater than 11, this is going to be an area or probability of 0.3. Okay, and don't forget those questions. You know, if they have done this in the exam, what's probability that x equals 11? Well, that's going to be 0 because the line has no area. Okay, so we're going to go over to its friend, the standard normal distribution. So z tilde n is 0 and 1. Okay, and what we're going to fill in then. So we know that this is 0, 1, 2, 3, minus 1 standard deviations, minus 2, and minus 3. And again, we're going to copy this straight over. Again, if it's not to scale, don't worry about it. You won't be penalised in the exam because you've drawn this slightly wrong. So this is 0.3. Okay, and we're going to grab the calculator, inverse again, and we're going to try and find out what number this is in terms of standard deviations. Okay, so I'll grab the calculator now. Okay, so with the calculator, distribution, normal, we're inversing because we know the probability, we know the area, if you want to think of it like that. Again, it's another right tail. The area is 0.3. mu and sigma are still the same. And so this is 0.5244. Sorry, just had to edit the video there slightly. I lost my numbers. 5244. Okay, we're going to use the formula again. So the Z score, which is over here, is equal to X minus mu over sigma. Again, we're going to fill in what we know. So we know that the Z score was 0.5244, and that's equal to, well, the X value is 11. 11 take away 10 over sigma. Quick rearrangement then. So 0.5244 sigma is then equal to 1. So sigma is equal to 1 over 0.5244. And so the standard deviation comes out as, just grab a calculator quickly. And it wants it to 2SF, so that's going to be 1.9. Okay, as I say, it's fairly easy to do, finding mu or sigma. Just make sure you use the formulas and make sure your sketch is correct. If it does go wrong, it's probably in these initial phases here. When students generally get to here, they're normally okay. And just check your rearrangements, don't make any daft errors here. Okay, so I would like you to get on with the exercise, but I've got a couple of summary pieces here for you. So this is let's talk about standardizing here, and this is what you guys need to know for your exam. So here, look, we're using X, and Z is reserved for this special distribution here, but as you've seen, is really useful, and obviously you need to know that as well. Okay, so I'd like you to complete questions. Just question 1 from exercise 21C. Pause the video, have a go at that now, get that marked up, build the confidence, and then we'll have a look at question 2 in a minute. Okay, so here's the next question, the next style of question. Anyway, we're trying to build up the skills as we go. So this time we've got a height of drafts are thought to be non-distributed. Again, something like height will be non-distributed. 25% of drafts have a height of more than 5.6 meters and 20% of a height of less than 4.5 meters. And this time we're trying to find the mean and the variance of the height of a draft. So this time we're not given really much about the initial distribution, but again, we can work with this. I'm going to be using the calculator a fair bit to do this. You can do the simultaneous equations by hand, but I'm probably going to use the calculator. Okay, so as always, get a little sketch. So we know if we let X be the height of a giraffe, X is normally distributed, and we don't know mu, and we certainly don't know sigma or sigma squared. Okay, but we do know some other things from it. So we know that 25% of the giraffes have a height of more than 5.6. So I'm just guessing here, 5.6 approximately. And because it said more than 5.6, the area of that section there is going to be 0.25. Okay, and over here we've got 20% have a height of less than 4.5 meters. Again, I'm just guessing where these numbers are, but I know roughly where they are, but I'm not sure exactly whereabouts on the line they are. So 4.5 meters, and we know this area here is 0.2. So this isn't too bad to work with at the moment. I'm just doing exactly what I did before. Okay, so here comes the standard normal distribution. Okay, so Z is approximated by the normal distribution, and it's 0 and 1. Okay, again, it's just a copy and paste job of what's over there, apart from the numbers are slightly different. So we don't know that. We know that the area, though, is 0.2. and we know that the area here is 0.25. So we're going to have to work on the two individually. I can't use a central tail on this one because this area in the middle here isn't symmetrical. This area here is slightly small, and that one other doesn't look like it. Okay, so I'm going to grab the calculator, work on these two individually, try and find out what these two Z scores are, and then we're going to work them both through the formula. I'll just grab the calculator. Okay, so here's a calculator. I'm going to do exactly the same thing that we've been doing for the last few videos now. So first of all, we're going to dist, we're going to norm, and we're going to inverse again because we know the area. So I'm going to start with this one. So this is a left tail, and its area is 0.2. And mu and sigma look are already in there from the previous bit, and that comes out as minus 0.8416. Normally take about 4 SF on this. Feel free to write down all the values if you want, but I'm going to just round them off to 4 SF. Okay, and after that we're going to do the right hand tail over here. So change that to right. The area is slightly different, and that comes out as 0.6745 to 4 SF. So I'm going to work on that now. Okay, so the left hand tail there was minus 0.8416, and this one here was 0.6745, and that tells you how many standard deviations away it is from the mean. I know I keep banging on about that, but it used to be on the ODS2 module quite difficult to get your head around what was going on, and part of that was because you used to get a table of values to convert all these, but you know, with these new calculators, it's so much simpler. Okay, so what we're going to do now is we're going to be using the same form as before, but we're going to get two equations, and we're going to go simultaneous. So we know the formula. We know that Z is equal to X minus mu over sigma. So I'm going to work on these two individually. In fact, I'm just going to put a line down the middle here, more for my handwriting than anything else. Okay, so let's look at this left-hand tail over here. So we know that this is minus 0.8416, and that's equal to, now that relates to the 4.5 figure there, 4.5 minus mu over sigma. Now notice I've got two variables but only one equation, so it can't be solved, or you're going to get, sorry, it can be solved, but there are infinitely many solutions. Now, or possibly no solutions. From here then, we're going to rearrange this and turn this into a way that the calculator will be happy with. So I'm going to have minus 0.8, oops, 416 sigma. I'm going to add the mu to that side. Okay, now the reason I've set it up like this is because your calculators will solve AX plus BY equals C in terms of simultaneous equations. So I've got variable equal to a constant there. Okay, going to do exactly the same thing on this one. So 0.6745 is equal to 5.6. Again, I'm just matching these two up. Minus mu over sigma. So 0.6745 sigma plus mu is equal to 5.6. Now, if you don't have one of the fancy Casio calculators, you can sit and do that by hand. I mean, you can see that if you just subtract one from the other, it's not going to be too difficult to do if you want to label them up. I'm going to be using a calculator because in an exam we want to guarantee a right answer, and you don't want to be at a disadvantage. And also, mainly down to time as well. It only takes one little slip and it possibly goes wrong in a normal calculator. So I'll pull up the calculator now and show you exactly what I'm typing in. Okay, so here's the calculator. I'm going to go down to equation. And this is a simultaneous equation, so I'm pressing F1. And we've got two unknowns. So we've got minus 0.8416. We've got one of those. And then we've got 4.5 on that side. Okay, and then for this one, 0.6745. One of those again, and 5.6. Okay, and press solve. Oops. And there come two values. So let me just jot those down. So again, I'll just take for these two, I'll just take a couple of SF for this. So I've got a, now remember from the calculator, let me press exit, this value here comes from the front of the sigma there. Just pull my calculator back up. And the 1 comes from the mu, so hitting solve. So I've got sigma comes out as 0.7255, so I'll take that 0.73, sorry. And mu has come out as 5. I'll just take it as 5.1, and that makes sense actually because it's in between these two. Okay, so just jotting the answer down, we've got sigma, the standard deviation, is 0.73, and mu in this case is equal to 5.1. Now, I'm always trying to think about what the examiners might do or might write. The question could then say, write down the distribution of x. And again, it would just be a case of them trying to catch you out. So x tilde, and it's normally distributed. We know that mu is 5.1. Again, I know I've rounded that off. And then I'd put a comma. And then I think that what they expect students to do then is write 0.73. We'd need to write 0.73 squared. So just watch out for that. Okay, let's say this is very, very nice to do. It does work out nicely. And if you've got one of the nice, fancy, expensive calculators, your life is a little bit easier. Okay, right. So here's another one of those. If you want to pause the video and have a go at this now, and then I will jot up the solution in a moment. Okay, so same thing again. We're going to work through this. So masses of beans, yeah, it's continuous. It's probably going to be normally distributed. If you think about a tin of beans, it's very difficult to get all the masses the same. Each individual bean has a different mass to every other bean, and they all have different, they all have different densities and things. But let's not try to think too much about that at the moment. So if 22% of the tins have a mass of more than 4.5, so sorry, 405, so let's think about where that's going to be. So 405 and 22% is more. Now 22% is only a small part of the graph. So 22% is 0.22, so there's a 0.22 instance probability chance of finding a tin of more than 405. And over here then, this tiny little chunk here, again I'm rubbish at drawing these to scale, that is 0.1, and that is 397. Now we're looking for a number between these two to find the mean. Now if we do the question, it comes out wrong. So the answer doesn't come out between these two, then we need to do something. But hopefully you've had enough instruction to work on this. So this is x here. Say let x be the mass of a tin of beans. So that's normally distributed, and we don't know mu, and we don't know sigma squared. Okay, so hop over here to our friend the standard normal distribution. And what's nice about this function is that we know everything about it. Okay, so just going to copy exactly in terms of areas from the other picture. So we know that's 0.22, and this area here is 0.1. Might be handy actually in the future not to put these numbers at the bottom, because my numbers keep coming out wrong and not actually fitting in there, but it doesn't really matter. So I'm going to grab the calculator, do the inverse, and then work from there. Okay, here's the calculator again. So distribution, it's a normal distribution. Again, we're going inverse because we know the probability. I'll start on the left-hand tail. Left-hand tail. It's in it. Oops. That's got an area of 0.1. And those two are left in there. So that's minus 1.282. Show that down. Minus 1.8. Minus 1.282. Minus 1.282. Okay, and its friend over here. Again, let me grab that calculator. Okay, so this time it's a right-hand tail. Got an area of 0.22. And those are still the same, and that comes out as 0.7722. So let's just jot that down. So that's an area of 0. Sorry, not a zero. Sorry, not an area. A z value. I'm trying to think about too many things at once here. So that's 7722. Okay, over to the formula. So the z-score, or z-value, is equal to x minus mu over sigma. I'm going to do the same thing again. I'm going to split my page into two. And you can write upper and lower or left and right tail above each one if you want. So minus 1.282 is 397 minus mu over sigma. I'm going to rearrange in one go. So minus 1.282 sigma plus mu is equal to 397. And over to this one, 0.7722 is equal to 405 minus mu over sigma. So 0.7722 sigma plus mu is equal to 405. So I'm going to grab the calculator again, simultaneous equations, and see what comes out as. Okay, so from the menu, equation, simultaneous, two unknowns. This time I'm looking at the coefficient of sigma there, so minus 1.282, 1, let's press across there, 397, and then this one is 0.7722, that's still 1, and that's 405. So what have we got then? We've got it's sigma first, so that's sigma is equal to 3.89. Again, I'll take that as 2SF, so I'll take that as 3.9. And we've got mu there at 401.99, and just for argument's sake, I'm going to take that as 402. So we have sigma is equal to 3.9 and mu is equal to 402, which is what we were expecting. Okay, so that's how to work out mu and sigma. Hopefully you found that useful. There's plenty of examples on there for you to work through. It is quite nice to do. I will say the stats part of the course is the maths is easy, but there's more stuff to remember. Whereas the mechanics, there's less stuff to remember, but the maths is, I find in general a little bit heavier, and I think a lot of students do as well. So would you move question 2 onwards? Certainly I would be expecting students to be able to do from questions 2 to question 7 at least. Certainly 8, 9, 10 are quite challenging, and people would like A stars really need to be looking at those. And so best of luck with that. Any problems, email me and I will try and get back to you. Thank you.